Hydropower is created by using the natural movement of water to drive large turbines, which rotate and generate electrical energy, turning a simple physical force into a stable source of electricity. To make this possible, water is collected in a reservoir and directed through narrow shafts that increase pressure, allowing it to hit the turbines at high speed, so every rotation remains controlled and consistent. The generator, directly connected to the turbine, converts this rotation into electricity, and modern systems monitor every step automatically to keep the output steady even when water levels rise or fall. Hydropower plants are designed to operate day and night because rivers never stop flowing, making this energy source independent of weather and capable of supplying entire regions reliably for decades. For people, hydropower means a dependable foundation, producing electricity without noise, without emissions, and without sudden fluctuations, giving towns, villages, and industries a power source that does not fail unexpectedly. The history of hydropower began many centuries ago, when people used simple water wheels to drive mills and perform heavy work long before electricity existed. In the 19th century, engineers developed the first turbines that could use water far more efficiently, allowing the movement of a river to be converted into electrical energy for the first time. During industrialization, large hydropower plants were built that supplied entire cities and proved that flowing water could provide energy day and night as long as the river kept moving. In the 20th century, reservoirs were constructed to control water flow, ensuring that power plants remained reliable even during dry periods and significantly increasing overall output. Today, hydropower is one of the oldest yet most advanced energy sources because new turbines, improved materials, and automated systems make the technology more precise than ever before. A hydropower plant begins with a large reservoir that collects and stores water, ensuring there is always enough pressure available to drive the turbines reliably. From the reservoir, a long pressure tunnel leads deep into the facility, designed so the water reaches the turbines at high speed and with controlled force. The turbine is a precise metal wheel with curved blades that rotates under the power of the water and transfers this movement continuously to the generator. The generator converts the rotation into electrical energy, and modern systems monitor every turn, every temperature change, and every pressure level to keep the output stable and prevent overload. Finally, the produced electricity is adjusted to the correct voltage by transformers and fed into the power grid, allowing homes, cities, and industries to use energy created solely by the force of water. Hydropower gives people an energy source that works independently of weather because rivers always flow and provide stable electricity even when other forms of energy fluctuate. For towns and villages, this means a reliable foundation as hydropower plants deliver electricity day and night without sudden shortages or dramatic price increases. Since hydropower produces no emissions, it improves air quality and protects public health by avoiding pollutants and keeping the environment clear. And the facilities operate quietly and cause minimal disturbance, allowing people to live near rivers without the noise of large machines or industrial activi. Hydropower also creates jobs in engineering, maintenance, and research, helping entire regions grow economically and remain stable over time. Hydropower plants face the issue that rivers in some regions carry less water over time because long dry periods reduce natural flow and can lower the output of the facilities. Heavy rainfall or sudden flooding can also stress the systems, as too much water creates extreme pressure that threatens turbines and tunnels and requires precise control. Many older plants are outdated and need modern turbines, improved materials, and new monitoring systems to remain reliable and avoid failures caused by wear and aging. Environmental concerns matter as well, because rivers must be protected, and plants must be designed so fish can migrate and ecosystems are not unnecessarily disrupted. For people, this means hydropower is very stable, but still needs maintenance, upgrades, and careful supervision to remain a safe and dependable energy source in the long term. Modern hydropower plants use digital control systems that monitor water flow, pressure, and turbine speed in real time, allowing the facility to react immediately when the river changes or output needs adjustment. Artificial intelligence analyzes sensor data throughout the plant and detects patterns that indicate wear or upcoming issues, enabling maintenance to be scheduled early before failures occur. Automated systems precisely adjust turbine angles and generator output, so every rotation is used efficiently and electricity production remains stable even when water levels fluctuate. New materials and advanced coatings reduce friction and protect turbines from damage caused by sand, debris, or strong currents, significantly increasing the lifespan of the equipment. For people, this modern technology means hydropower plants operate more reliably, more efficiently, and more safely, delivering long-term energy without constant repairs or major interruptions. The future of hydropower is shaped by new turbines that are lighter, more efficient, and more durable, allowing even small amount of water to be used more effectively and increasing the energy produced from every liter. Researchers are developing systems that control water flow more precisely by using digital models that predict river behavior and adjust plant output automatically before fluctuations occur. Small modular hydropower plants are becoming increasingly important because they operate without large reservoirs and can supply remote regions, making countries more independent with less infrastructure. New storage technologies improve pump storage plants, enabling them to react faster, store more energy, and stabilize the grid even when consumption changes sharply or other energy sources For people, this future means hydropower will become even more reliable, flexible, and environmentally friendly, playing a key role in helping nations build a secure and stable long-term energy system. The future of hydropower is shaped by new turbines that are lighter, more efficient, and more durable, allowing even small amount of water to be used more effectively and increasing the energy produced from every liter. Researchers are developing systems that control water flow more precisely by using digital models that predict river behavior and adjust plant output automatically before fluctuations occur. Small modular hydropower plants are becoming increasingly important because they operate without large reservoirs and can supply remote regions, making countries more independent with less infrastructure. New storage technologies improve pump storage plants, enabling them to react faster, store more energy, and stabilize the grid even when consumption changes sharply or other energy sources For people, this future means hydropower will become even more reliable, flexible, and environmentally friendly, playing a key role in helping nations build a secure and stable long-term energy system. Hydropower remains a central pillar of energy supply because it provides baseload electricity that is available regardless of time of day or weather, forming the foundation on which other energy sources depend. It stabilizes the power grid by balancing fluctuations caused by consumption peaks or irregular input from other sources, ensuring reliable electricity for households and industry at all times. With its long lifespan and low failure rate, hydropower plants often operate for many decades without major reconstruction, making them one of the most durable technical solutions available. At the same time, their output can be controlled precisely, allowing them to deliver more energy exactly when it is needed and giving them an important role in long-term national energy planning. For people, this means hydropower is not just an old technology, but a modern, stable, and essential part of a dependable energy system. Future hydropower plants will use turbines made from lighter and more durable materials, allowing them to react faster, lose less energy, and operate efficiently even when water flow is low. New surface coatings will reduce friction and protect turbines from sand, debris, and strong currents, increasing the lifespan of the equipment and reducing the need for frequent maintenance. Digital models will simulate river behavior in advance, enabling plants to adjust their output automatically before the flow changes, making electricity production more stable and precise. Artificial intelligence will monitor the entire system, detect early signs of wear, and calculate the optimal turbine speed, allowing more energy to be generated from the same amount of New construction methods will allow smaller, modular hydropower plants that work without large reservoirs while still delivering strong performance, giving remote regions access to modern hydropower. For people, these advancements mean hydropower will become stronger, more flexible, and more efficient, playing an even more important role in future energy systems. Hydropower shows how powerful energy can be when it comes from the natural movement of water and is used with modern, precise technology, turning a river into a dependable force for entire regions. It combines centuries of experience with new advancements and proves that an energy source does not need to be loud, unstable, or complicated to support people reliably for many decades. For the future, hydropower means stability because it delivers electricity exactly when needed and continues to evolve, becoming more efficient without losing its natural foundation. And this film ends here, but the story of hydropower continues as science, engineering, and nature together reveal how much energy every river holds and how important this force will remain for future generations. If you enjoyed this film, I appreciate your subscription and a like, as it supports the creation of future projects and helps keep content like this out. Thank you for watching.